Everyone, hope you are doing great. Thank you so much for signing up for this session and thank you so much for tuning in. So, today we are doing a lightning session, meaning 15 minutes of the session where we'll be talking about what is shift left performance testing. So, before we kickstart, a quick introduction about myself. I'm a QA and a performance architect. I work in an MNC. I have about 15 years of IT experience. And I've also founded the association with the name American Association of IT Professionals. Uh, we normally talk about the latest technology trends. All technical webinars are hosted through that. We are almost 820 people strong as of today. I do ask you to go check it out, follow, and be part of it and collaborate. So we have also launched a campaign for collecting articles to be published in a journal. It's a superb opportunity. Please submit if you have any articles so that it can be reviewed and you'll be featured and it you'll also get a certificate. So yeah, do check it out. So before we start talking about the shift-led performance testing, I just want to make sure I level set if there is someone who is not from performance testing background. So what is performance testing all about? It is nothing but a non-functional testing where we ensure an application which is built is good in terms of performance. That means it is able to behave and respond within the time we want it to, and also it can handle multiple users at a time. We do conduct a couple of type of executions to make it happen. Few of them are load, stress, spike endurance, scale, and volume testing. So now that we know what performance testing is, let's talk about what is shift left performance testing. So traditionally, being in performance testing team, usually you might have seen performance testing is almost at the end of the cycle. Like development of a product needs to be completed, unit tested, integration tested, and functionally stable. Only then performance testing would happen. And what happens is most of the time when performance testing is done, we uncover so many performance related issues. It goes back to fixes and development team has to redo it. Again, it has to go through the process of testing again, and then comes to performance testing. So it adds a lot of overhead and also time. And most of the scenarios I have seen, performance testing is not planned in such a way that multiple cycles can happen as well. So it's very important for performance testing and engineering team to make sure the testing starts well ahead of time. So the continuous feedback can be given to the development team so that they can make the changes or the fixes as they go. As you can see in the graph, which is showcased below, in the traditional model, the attention to quality is almost given at the end during the testing or whenever we are ready to deploy and release, because only then the development team is usually concerned about the quality of the code and the coverage and how well it is built and if there are no bugs. But shift left model try to flip it and starts in parallel with planning, design, development, so that most of the testing, so most of the stability of the application is evaluated in the beginning itself. So that way, in the later part of the cycle, you know you have built a quality product. So it always makes sure the timeline and the release of the product is maintained. So let's talk about shift left mindset. So one of the biggest challenge I've seen is getting everyone to buy in on the concept of doing a shift left performance testing. You will also get a lot of pushback from development teams because they do not have time for themselves to create a product first, and they don't want to really bother about the feedback from performance testing team and start improvising on top of it. But one thing we all have to understand is it is not adding any additional work or overhead. It is making sure the product is built up to the standards. So it ensures the faster time to market. So developer teams can also gain an insight into the performance degradation in the recent code commits and when they're getting built from the scratch. So that way, the product is built with much higher standards, and later stage there are low chances of having performance related defects. So this is the challenging part, till we get everyone into the mindset of doing a continuous testing or doing a shift left performance testing where the feedback should be taken positively. So do have a good conversation with your team or a product owner or a business team with all the stakeholders and showcase the advantages of doing this and I'm pretty sure they will be more than welcome to have it part of their testing cycle. So now we know what is shift left performance testing. So how do we do it? So shift left, basically, the performance evaluation will have to happen parallelly with development, and we will be sharing a continuous feedback and fixes so that that can be handled at the grassroots level itself. So since the UI is normally built out or the APIs are built out first, we can definitely start looking into those. So here we won't be targeting a high volume load test. So our intention is to do a single user type of a UI performance evaluation and see if there are any fixes which can be suggested earlier in the game. And also, it's very important to meet frequently with the stakeholders and discuss on the reports and findings we have so that it can be included in the release cycle or a sprint so that it can be fixed then and there itself. So we'll talk about three approaches which we can possibly take to do it. First thing is make use of the Chrome extension called Lighthouse tool. So what this tool does is it will audit your UI page and it will create a report which is comprises of the scoring out of 100 for performance, and it will also highlight what will be the areas which can possibly be fixed to improve the performance. So here you really do not have to build any code or any script ahead of time. You can use this as is. If you have challenges with a firewall or company policy to install um, Chrome browser extension, you can also use this in the developer tool. There is an option available. You can use it. So this is one of the very important concept, and there is a lot to learn and go through. So probably I'll be doing one more session specifically on how to do a UI performance evaluation using the Lighthouse tool. In that session, we'll be talking much more in technical details of how to create the report and use it. So second thing is service virtualization. Pretty sure you would have heard this term. So whenever you have any services being built out or an API being built out, uh, there are certain ways APIs are built. It can have one or many APIs tied together, or it could be interacting with a database or a different system outside or a third party system. So a lot of the times when a product is built newly, they will not have all these services up and running at the same time. They have to go one by one. So you can do a service virtualization, meaning you will mock up a response similar to what you would expect from the other part of the service, and you will receive the same response back. So you're virtualizing the service instead of receiving the actual response. And that way you can still continue with your end-to-end testing, and you can still uh, try to focus on doing some level of performance evaluation on these services. The last thing I would suggest is to do shift left load testing. I know when we talk about the load or volume test, usually we target a very high concurrent volume, but it need not be at that level. So initially, let's assume UI, one of the screen is built out of the total functionality. What you can do is just script the very first screen and probably do some level of load testing there. Go with a smaller load, be it one is to four or one is to two, and try to see how things are behaving at that load. If you see there are some performance challenges, you see there are SLA degradation, you see the rendering time is low, you have a lot of problems with the screen then and there itself, then start discussing that back to the development team and see where it can be fixed. So, and later when they start building further screens into the functionality, you can always include that and create the script or rescript the entire flow again and have load testing done for the two screens instead of one. So you can incrementally do load testing, and once the functionality is built end to end, then you can switch to the full-fledged volume or a load testing. So the advantage here is you're testing it early. Any challenges with respect to script creation these days with a single page application, it is even more difficult to use the existing protocols to create them. So you will definitely have an edge, making sure the scripts are working end to end. You will have ample time to fix any issues you have from your side as well. So these three are a possible approach we can take for the shift left testing. So let's talk about some key performance indicators. Normally, when we talk about performance testing and the indicators are different, we would like to know in terms of user, the infrastructure, the SLA. But when we talk about shift left performance testing, we're really not talking about the end product. So the performance indicators might be slightly different here. So a few of the things you can readily target is single user response time, how much time it takes to render, and data related errors if you face, and also any application level errors and failures. If you get any 500 errors or internal server errors, you can also identify any high running SQL queries which needs to be tuned. And if there is any possibility of text compression enhancement, that's one good area where you can improvise on the overall response time. So keep in mind the key performance indicators uh, change slightly because we're not dealing with the entire volume or the load test at this point. So now let's talk about the reporting side. So reporting is one such area where you really have to be very careful. Um, you have to create a comprehensive report and highlighting what is the possible fixes and before you go and talk to the stakeholders. So do brainstorm and have ample time for retesting and have enough time to discuss on the possible fixes and implementation strategy. The screenshot you're seeing right now is actually a snapshot from the Lighthouse tool. You can see there is a score for performance. It has score 25, meaning there is a enough opportunity for this web UI page to be improvised overall. And just below that, you can see there are some metrics, the contribution, the speed index, the contentful paint, and time to interact. So there are some areas where it says it's slightly higher than what it can be, should be. And once you expand these, you will be given much more detailed explanation about what it is and how it can be improvised. So this is one of the snapshot from Lighthouse. You will get a similar report. You will be able to completely go through a deep dive, understand the areas where it has to be fixed, create a comprehensive report out of it so that the dev team can take it up and start implementing it. So now that we talk about all that, so why do we actually have to do shift left performance testing? So what are the benefits we are trying to chase here? There are few I would like to mention. The first one is the agile approach because in the previous session, I talked about how best we can do agile in 2 week sprint. Again, we talked about the challenges with performance testing. We're doing in sprint and doing n minus one or hybrid. So with shift left performance testing, you're actually enabling the effective agile approach where you're continuously improvising the product and giving a feedback and you're continuously testing it. So that's the first advantage. The efficiency of your product will go up and your time will be used much more wisely. That's the second advantage. And reduce costs. So it translates to the rework, which is going to be reduced with the early performance fixes. So you really don't have to go to the end of the release and realize the performance is not optimal, and then you have to spend more time and effort to fix them, retest them, and release it. So the cost will be reduced overall, and the team will be at the higher velocity. So there won't be any idle time. Team can be utilized much more effectively with this, and again, reducing rework for development team and also to performance testing team. So these are all some major benefits we can see by adapting to the shift left performance testing. So that's it. I hope this session was helpful. You got some value out of it. The intention was to just introduce you to the idea. Definitely, if you are not doing shift left performance testing currently, please incorporate. There is also a concept of shift right performance testing. We will talk about that in a different session. That being said, feel free to join our American Association IT professional group in LinkedIn. I've provided the link here, and also I would love to have a professional connection in LinkedIn. That's my profile link. Please go ahead and connect, and we will definitely meet in future session and continue to discuss on performance testing and engineering activities. And if you have any comments or any suggestions, if you want to share what your team is doing, please feel free to write it down in the comments. I would really appreciate that. Thank you. Take care.